Hi students, I am Sandhya, Assistant Professor, Department of Mathematics in SNS College of Technology. In this previous class, we are going to solve the problem in the diagonalisation. So in this class, we are going to continuation of the previous class. So in this previous class, we saw how we can find the eigenvector. So using this eigenvector, we are going to solve. It is a diagonal form. So in this diagonal form, only the eigenvalues are occur in the diagonal elements, that is the value. So we are going to using the steps. So in this previous class we saw what is eigenvector. So next we are going to check in this eigenvector is a pairwise or not. How we can check it is a pairwise orthogonal or not. So in this pairwise orthogonal is x1 transpose x2 equal to x1 transpose is 1 0 0. Then so here transpose, we take the transpose is the column is transferred into row. So x2 is 0 1 1. So here see 1 into 0 is 0. So again 0 into 1 is 0 and 0 into 1 is 0. So the answer is 0. So if it is that we take the left hand side, the right hand side is 0, it is a pairwise orthogonal. So similarly we want to check x2 transpose x3 equal to 0. Then x3 transpose x1 equal to 0. Therefore the eigenvector is a pairwise orthogonal. Pairwise orthogonal. Then in this eigenvector we have to find the normalized eigenvector. So in this normalized eigenvector formula is x1 equal to x1, x2, x3. This is the element of x1. So then we want to divide in L of x. What is the L of x? L of x is nothing but every element of square, that is x1 square, x2 square and then x3 square. So using this formula we have to find it. So here 1 square, 0 square and then 0 square. The answer is 1. So here 1 divided by 1, 1 divided by 1, 1 divided by 1. So the answer is 1 0 0. So this is the first normalized eigenvector. So then we want to find the second normalized eigenvector. So this is the eigenvector. So here we want to find the L of x. What is that? Root of 0 plus 1 square plus 1 square, that is root 2. Then 0 divided by root 2, 1 divided by root 2, again 1 divided by root 2. Then we have to find the that is third normalized eigenvector. So here we using this vector, we have to find the third normalized eigenvector. So 0 square, then minus 1 is whole square, then plus 1 the whole square. So we get the answer is root 2. So the answer is 0 divided by root 2 minus 1 divided by root 2, then 1 divided by root 2. So combining this eigenvector, we get the normalized eigenvector. So this is the normalized eigenvector. So combining the normalized eigenvector is a normalized model matrix. What is that? Normalized model matrix. So this is the normalized model matrix. So in this normalized matrix it should be a orthogonal. How we can check it is a normalized model matrix is a orthogonal. So n transpose equal to I. You know this is n. So if it is changing the row into column, that is n transpose. After the multiplication of n matrix and n transpose matrix, we get the I. So what is I? 1 0 0 0 1 0 0 0 1. So n should be a orthogonal. Then we are going to move on the final step. You know all the entries, that is n transpose A n. So here this is the n matrix. So A is a given problem. So n also you know. So combining all the three matrices, we get the answer is diagonal form. In this diagonal form, the diagonal elements are eigenvalue. What is that? The diagonal elements are eigenvalue. So this the diagonal form of the given matrix. Okay, so in this class we learned what is diagonalization, what problem is given, we are going to solving the diagonal. Okay, diagonal form. In this diagonal form the eigenvalues are occur. Okay, thank you.